Hello, I'm Tom Nahumi from DELL EMC XtremIO, and today I'm going to show you a demo of protecting VMware environments using DELL EMC XtremIO all-flash array and DELL EMC RecoverPoint for virtual machines 511. RecoverPoint for virtual machines is a software-only data protection solution for protecting VMware virtual machines, enabling replication from any data store type to any data store type, leveraging virtual RecoverPoint appliances integrated in the VMware ESX hosts as part of the VMware High Availability cluster. This is achieved via a RecoverPoint write splitter embedded in the ESXi hypervisor. So first of all, let's take a look at my vSphere environment. As you can see, I have two vCenter servers in a shared SSO domain, production and DR. Each one is connected to a dedicated XtremIO X2 single brick. In addition, each sites contain RecoverPoint virtual cluster, which runs two virtual RecoverPoint appliances. The production environment contains intensive I/O virtual machines, which reside on a production XtremIO X2 data stores. In this demo, I will replicate one of them to the DR site using RecoverPoint for virtual machines 511. Starting with version 511, RecoverPoint for virtual machines uses standard IP communication between the splitters to the VRPA on the same site. There is no longer need for iSCSI communication. Splitters to VRPA IP communication is supported from vSphere 6 and above. This means that communication between the splitters to the VRPA on the same site can run on a regular vSwitch or distributed switch. Now let's take a look at our storage arrays. In this setup we have two X2 bricks. XBrick 5115 is the production array and XBrick 5110 is the DR array. We can see that the virtual machine generates approximately 30k IOPS and about 1.7 GB bandwidth, when the bricks serve the above load in less than 0.6 millisecond latency. If we jump over to the Performance tab, we can see the overall performance and the read versus write distribution. Looking at the Blocks tab will show us the various block sizes that this application generates. We can see that most of the blocks are 16, 64, 128 and 256k IOPS. So let's go ahead and configure replication for one of my production virtual machines. RecoverPoint for VMs is fully managed from the vSphere web client. By right-clicking on the VM and navigating to RecoverPoint for VM options, I can access the Protect wizard. Here, I'm creating a new consistency group, specifying the name and selecting the production RecoverPoint appliance cluster. Next, I can select the name of the production copy and the journal location. In RecoverPoint 511, the journal can be created automatically on one of the connected data stores. Here, the replica copy name is then assigned and the remote VRPA cluster is selected to facilitate the creation of the remote replica copy VM. The replica copy VM settings are then selected, including the replication mode and the journal configuration. RecoverPoint 511 for VMs supports both sync and async replication, and even combining both modes to a different machines in the same consistency group. A replica ESXi host resource for the copy VM is selected, along with a data store for the copy VM. This option exists to create the replica VM on a designated data store or alternatively on an existing virtual machine. Where the option to use existing replica VM is selected, a sanity check of the replica VM is undertaken to determine if the virtual disks are identical in the size of the protected VM. Similar to Site Recovery Manager, RecoverPoint for VMs now allows the user to define a failover network. Now, let's click Next and Protect to start the replication. Once the VM is protected, the status of the VM can be viewed from both RecoverPoint for VMs tab under the Manage option of the VM and from the vSphere web client via the RecoverPoint for VMs management option from the production vSphere web client. Once the replication has been initiated, RecoverPoint for VMs starts replicating the virtual machine's data between the production data store and the DR data store. As you can see, a shadow VM has automatically been created at the DR site. The test copy, recover production, and failover tasks can be initiated from the VM or consistency group, but each activity affects the consistency group and all the VMs within it. Both the recover production and failover tasks initiate a prerequisite test copy prior to the recover or failover activity, as this is a mandatory step to allow customers to check the integrity of the VM prior to completing the recover production or failover task. Now let's go through the various available options. Test copy. RecoverPoint for VMs allows you to select any point in time for testing a standalone activity or in conjunction with the failover or recover production recovery activity. Note that the use of test copy also provides a recovery capability, as it potentially facilitates individual file recovery. Production recovery. Recovering production restores the source VM from a replica copy VM at the selected point in time using the snapshot production source to a previous point in time. The last one is failover. The failover process of failing over a replica VM in the event of a disaster of the production site allows the system operations to continue from a replica copy VM. During failover, transfer is paused and access to the original production source VM is blocked. Failover promotes the shadow VM at the replica to the role of production. The original production VM becomes the replica copy, adopting the role of a replica copy with an RP prefix and shadow extension. Now, let's run a failover process. First of all, I'm selecting the copy I created earlier and then the image. RecoverPoint for VMs allows me to select the latest point in time, a specific point in time, and select a bookmark from the image list. In this demo, I'm selecting a specific bookmark. Next, I'm selecting the option to create an isolated network for the machine and click Failover. Going back to our XtremIO bricks, I can see that the machine is still running at the production site and generating load on the array. If I go back to the vCenter, I see that the failover completed and the virtual machine is running now from the DR site with .copy extension. If I take another look at the XtremIO bricks, I can see that the load on the production array has stopped, and the virtual machine is now generating I/O on the DR array. I hope you find this demo useful and thank you for watching.